Thank you for the warm welcome. Is everybody having a good GDC? Good Tuesday, everybody? Yes, yes. Woo! Thank you for coming. Real pleasure. We're going to be talking about how we're going to maximize efficiency and creativity with AI for game asset creation. And I'd like to advise you, safe harbor statement, don't make your plans based on what I'm going to say today. AI is having a moment. I don't need to tell you this. We're all grappling with this as individuals, as industries, as companies. And not a day goes by without another news article about another AI model drop or another doomsday scenario, how we're all going to go south. And in moments like this, I tend to go back to first principles and look at what we have. We do have this definition, at least at Autodesk, for what AI is, and that is, I'm going to read it because they're good words, the theory and the development of computer systems able to perform tasks that normally require human intelligence, and in some cases will surpass it. What's embedded in here is that for us as a company, it's important that we empower humans, and we are measuring the algorithms and the systems whether they can live up to our expectations. That's what I'm here to do at Autodesk Research and Autodesk, and that's why I think this is an important definition. Furthermore, Jan LeCun recently on the Friedman podcast, in case anybody listens to that, said, do not worry so much because autoregressive LLMs are really quite dumb about at the level of a cat, and they cannot plan. They cannot respond to changes in the environment. And that is namely because they do not have a world to live in. They cannot get a feedback loop. If I make a mistake, I learn from that, but they're just simulating a kind of very useful, but altogether not very scary reality. So what is going to make these things more useful for us at Autodesk, and that's why I'd like to talk about Autodesk history a little bit, is to create a world and understand the world and measure a world in which AI can do the right things for us. And for those of you who follow Autodesk, we've had an AI lab since 2018, work in the space for an even longer time, since we've started writing academic research papers that are peer-reviewed. We've had over 65 papers specifically around geometry, measuring the world and understanding the world that drive the research in this space. So if you're calling us obsessed with geometry, we'll say, thank you very much. This is the let's call it the attendant technology to AI, generative AI, is generative design. And that employs simulation and physics. So in other words, an understanding of the world in order to create geometry. We've been at this for quite a while and also have papers out on that topic. Again, building that bridge between the real and the virtual. And there is a learning for all of us here because you do need to have the precision of generative design where you can say, I want to have a certain stress on a certain bolt, and that produces the geometry that I need to drive the car or keep the building up. So a lot depends on this being right. And that precision, that control, authorial control, that transcends physics and reality because what matters to us, which is the architecture of a story or the mechanics of the play, are elemental to the experience and important for us at Autodesk. And it, of course, comes with a responsibility, too, that we get this right, ethically speaking. We will not abuse data ownership by others. We are respectful of the artists and of the engineers who created all of this. And it's one of the reasons why I'm personally involved in this space, because I feel as a technologist I have a responsibility to get that right. Even if it puts us at a disadvantage, do not be disrespecting other people's property. And just to close it out, I do come from the movie industry, and I've worked on all of these movies. And beyond the ethics, I also have a moral responsibility, I feel, to artists that I had the pleasure of working with and on movies on. And that's why I do my work in media and entertainment research today. I'll give you just a brief hint of it. Don't want to be too long, but we are working from intern to the senior principal research scientists are investing in AI, including this intern project where somebody helps with the world building, or a process where you can use a natural language to drive Maya and build scenes up. I'll be quick with this. And again, coming back to me personally, my current obsession, without question, is geometry and how we understand it, because I want to build a bridge between all of our industries. So as part of our desire in building workflows that speed up our customers' creative processes, I am very thrilled to be the first to announce that Autodesk has made an investment in Sloyd as a revolutionary generative AI technology, and that will transform 3D art creation. By enabling rapid generation of geometry through text, this technology will have a significant time and money saving for game devs, and will enable artists, empower them, in fact, to create better, bigger, and more immersive games. So we're thrilled about this venture together, and we're looking forward together to further be enhancing the 3D art creation industry. So it is my pleasure to call Andreas up to the stage. He is the CEO of Sloyd. Give him a warm hand.
Thank you. Oh, I got a little taste of music there too. Cool. Thanks for coming, everyone, and thanks for the intro, and of course for this amazing opportunity to partner with you, and now to share a bit about what we're doing at Sloyd. So essentially what we're doing here today is I'll give you a brief intro to our company and to what we've been up to the last few years, and my co-founder Avi will kind of take a broader look at Gen AI in general in 3D, and then kind of explain a bit about how we do things. So first of all, here we go. So our story actually started 7 years ago. And now, so we incorporated around 3 years ago. We're now 13 people distributed across the world as we're a distributed team. And on our web app, we have over 200,000 people using it, which is obviously really great for us. We're super proud of that. Coming from the game industry, and have some of the best investors that we could dream of to have part of the team. But yeah, we started 7 years ago, so it all really started with this indie game. The vision was to be able to make this type of GTA open world game as a solo developer, with like an emergent world where everything is generated as you play the game at runtime. So it really started with some experimentation around that. Assembling vehicles in this case at load time. So that was just kind of the first procedural experiment, and that spiraled into full runtime generated vehicles. And then adding all the physics and game mechanics and logic on top of that. Just having a bit of fun. Yeah, and fast forward a few years, and we are here today, building on this legacy of kind of runtime world generation. That's always been kind of part of what we wanted to do things really fast at scale. We have two main products today. We have our web app, where you can customize and create 3D objects through prompting and also through sliders and toggles, like direct customization. So for us, it's like, we don't really like when you have to prompt and wait like 5 or 10 or even 50 minutes for the results. So we're all about like that instant feedback, meaning you have a bit less of kind of flexibility in what you can create, but you get that instant output and actually optimized output too. And we do focus on hard surface type of objects, not so much characters and humanoids and that kind of stuff. So it's all about like vehicles and buildings and props and weapons and that kind of stuff. And then we have our infrastructure. So it's basically an SDK and APIs where you can connect it to your games or to your platforms and just get the objects straight into that platform. So we, through this, want to enable like runtime generation of worlds. But it could also be just straight into like Maya or straight into Unity or whatever, where you just, you can just prototype and get something out there really fast. Yeah, so for us, having game-ready objects has always been really important. So we do this through a few different ways. First of all, the topology is really important to us. We have an LOD setting, like a slider that's runtime that you can just change the LOD directly. And the parts are separate, as it says here, so you can animate things really easily and that kind of stuff. So that's, and we have a UV system that's also runtime, so you get automated UV maps and that kind of stuff. So yeah, this sort of stuff is just the most important thing for us, that we can work within the existing workflow, that is just easy to work with, and you don't have to do like a lot of hoops to get around to a useful output. So this is typically how people use this today, either in pre-production, in production, or in live ops. So in pre-production, we work great in like that prototyping phase where through the API or the Unity SDK, you can just get the objects right into the engine and get a scene, get a little game going really fast, and you can still customize the objects in the engine, or in production, where you use this kind of as a starting point for customization, adding your own textures, adding more details, and so on, making them a bit more intricate and that kind of stuff in like Maya or 3ds Max. And then in live ops, going back to kind of the game engines, you can actually allow the gamers themselves to customize. So that's part of our vision here too, is allow anyone to kind of fool around with 3D creation and take customizability and UGC kind of to the next level through this. So now I want to kind of show you some quick demos. So that's just a quick glimpse of how the web app works with using pure prompting for both spawning an object and then customizing it. And now I want to show you kind of how it fits into the wider workflow and taking the object into Maya as well, and then finally into Unreal. So this is like the endpoint of this model that you'll be, or that we'll be creating here. So it's like the same base model that we just saw in the other video. But here you can see it's actually like customizing through the different kind of selection options that we have, which are all kind of parametric. Here also adding some stylization through asymmetry and some tapering on the whole kind of object through our wackiness sliders. And here just kind of, sizing it down a bit. Yeah, and that's it. Hitting export, and then taking it into Maya, just having a quick look at the UV. So you see we have like 4 different material slots. So the UVs are are separated that way, so you can assign materials really easily. Like here, you can just kind of drag and drop them. And this is a feature with built-in materials that we're going to release in the coming months too. So here, just making a few more variations of the same object, throwing some tileable textures on there and placing them out in a scene, and grabbing a gun model from Sloyd as well, adding some animations, and then adding something to shoot at. This is just a super rough prototype made in a few hours, but it kind of gives you the idea of how we can use Sloyd to prototype really fast. And he hit 26 points. And so the next one, I just have a couple more. Put on autoplay on that one. So this is just a scene we made with all Sloyd objects and our materials, just to kind of showcase how a more, slightly more realistic scene might look with Sloyd assets. Just a couple more screens of that scene. So I think it looks pretty good. And then obviously it's some of the shapes it could be more organic and more rounded and that kind of stuff. And that's capabilities that we're adding actually these days to do more like creatures and organic stuff. And everything is here is from Sloyd except the tree though. So vegetation also is something that we don't currently do. Last kind of render or example here from a more of an indie type or stylized game or scene. So this is just with the default materials that any object comes with. And then finally, just a showcase of the SDK. So here, you can see all the assets here are being regenerated and randomized fully as you're actually playing the game. So this just kind of showcase the runtime capabilities of the generation. To kind of give you an idea of how you might use this to create, more emergent, more immersive games where the environment changes as you play. And that's it for me. So now to go into a bit more of a deep dive into GenAI at large and a bit about how Sloyd works. So please welcome to the stage Avi Latner, co-founder.
Thanks, Andreas. Let me start by checking the clicker. OK, it's working. So yeah, there's so many use cases for GenAI in game development, writing storylines, composing audio, NPCs. We're going to look more into the visual aspects of GenAI within game development. And I think there are 4 main categories for that. Concept art, right, using text to image, and maybe some other smaller niche areas like doing skyboxes, or if you're in a 2D game, you could also do asset creation, texturing, animation, and 3D modeling. So we're going to look at the last 3 of those. Quickly going to go over texturing and animation, and then focus more about 3D creation, because that's kind of Sloyd's focus. And kind of I'll try to give a bit of a broader perspective of it, and then go into how Sloyd does things and how we think about it. So yeah, before we go into each one of those use cases, let's look at adoption. How much are these tools being used right now? And you may have seen this one. This is from the GDC annual survey, right? 3,000 respondents, and they were asked if they use GenAI tools, and 50% said either that they use it or their colleagues in their department use GenAI. But if you look at it by department, so you could see the top category is business and finance, then there's marketing and management, and then programming, and all the way down 21% in game design, and just 16% of visual artists or in visual arts use GenAI in their work. So it seems like usage is more kind of, I guess, the GPT chat kind of use, right? So it's kind of general use at this point and not so much specified into those tools. Looking at it from a different survey, so this one is from last year, done by HCC with a smaller sample. And to the left, you could see people were asked what tools they're using. And so the most common tools are text tools, LLMs, Copilot, and stuff like that. Of course, GPT chat. And then there's like also image creation tools are widely used. So they're the general tools, perhaps for concept art. And then there are like specific tools for image creation for games, like Scenario and Leonardo AI. Right, you could do 2D assets with them. When it comes to tools that like could possibly be used for 3D modeling, for animation and stuff like that, only a handful of respondents said that they're using it. But then to the right, you could see what the same respondents think about what they're about to use or planning to use. And 33% are planning to do texture creation and PBR materials with AI, and 48% are planning to do 3D asset generation. So at least there's a will to have a lot more adoption. Going on to texturing, and we'll go through this a bit quickly. So to the left, right, there's a picture of kind of like tileable textures, and there's quite a few tools right now that are doing AI creation of tileable textures. A lot more, and materials, a lot more than tools that are doing kind of like painted textures, like in the picture in the middle, which there's not a lot of that, and it's also not nearly as successful. When it comes to AI-generated textures, I think it's not bad. Still, the resolution is not always, I think, as you would expect. And it's especially challenged with creating textures that are seamless. Then there's also a challenge, if you look at the picture all the way to the right, at taking this one image and creating multiple maps out of it. I mean, that's a possibility that tools offer, but the quality is not always great. But then again, this is an area where there's a lot of research on right now. There's one example here, like flash text. It's one of many. And so I expect this to improve a lot, even within this year. On to animation. So one startup or tool worth noting is Wonder Dynamics, which is actually in partnership with Autodesk and has a plugin into Maya. And they have really impressive demos on animation Gen AI. But I'll go through a few use cases of animation using a few other startups that I know. So the first one is Kinetics. In this case, they're doing motion matching from a single camera video. And that's like really low effort, easy to do. It's used, I think, more in like UGC, right, players within the game than in the production phase. Another company to note, and another method, Metorica. And so they're doing character animation, applying Gen AI generated style and a motion path to a character, and they can even make characters dance to music. And you know, while most animation focuses on humanoids, Anything World also does a lot of animals and stuff like that. So you could like take a 3D model, upload it to the system. The system auto-rigs it, and then you can apply a motion sequence to it. And I asked my colleagues in those companies what they think about adoption and what's hindering adoption right now. So here what they said, like, so first of all, quality. When you look at like traditional motion cap and you compare them, the quality is still better in those traditional methods. Then there's kind of like a tipping point that you need to reach where there's a benefit and cost saving that you get from using tools like that. But then there's also an investment that you need to do in like switching the processes that you work with. And for most studios, that tipping point hasn't come yet. Specifically, AI is challenged with subtle body dynamics. It's challenged at retargeting into different skeletal dimensions, into working with skeletons with like a lot of detailed rigs. And everybody seems to say that there's not enough data to do all the training that they want. OK, so now on to 3D creation. And so I'm going to take you through what I think are the main breakthroughs in Gen AI when it comes to 3D. And I'll start in 2018. At that time, it was GANs, like occupancy network down below there. And in GANs, you had to train at each domain at a time. So let's say you wanted a 3D generated airplane. You needed to collect lots and lots of models of 3D airplanes, put it into the neural network, and train it, and it would be able to produce new variants that look pretty good, at least if you look at it from zoomed out. Right. 2020, NERFs came in, and NERF has the ability to take a single viewpoint or a few viewpoints and create a complete scene out of it. And if you take NERF and go, create a 360 view around an object, then it becomes kind of like implicit photogrammetry, and you can use it to create a 3D object. So NERFs they still are very impressive, especially in videos. A year after that, 21, we're starting to see text creation. Clip to mesh at the beginning of the year, or text to mesh at the beginning, and then the early 22 clip to mesh. And this is already pre-trained models, unlike GANs, right? So you could have everything created, but only from basic text prompts. Then diffusion came into 3D the year after that. So the top there, Dream Fusion, was done by Google. The lower one, Magic 3D, is by NVIDIA. And what the researchers there have done is they've put together diffusion and NERF together. So you start with a text prompt and turn it into an image with diffusion. And then you take that image and using NERF, create an object out of it. And with that, you could already create anything you want, even with like very detailed text prompts, like you used to do in images. But inference, right, the time it takes from input to output takes about 40 minutes. It's a long time to wait. 23, last year we had Gaussian splatting, which is an alternate technology for NERF for implicit photogrammetry. But it could produce the same quality or maybe better quality faster, so time went down to 6 minutes of inference. Right? If you look at the best companies, I think, that do this type of things, they're probably using, you'd have to ask them for sure, but they're probably using a diffusion with Gaussian splatting, so CMS, Meshi, LumaAI, to name a few. Right? So this is the whole flow. And you can see there's literally a breakthrough every year. And we can look at the trajectory of improvement along two axes. One is the improvement in inputs, and the other is the improvement in speed. So we started like by having to have as an input lots of 3D models. Then we went to maybe a few images or a single image. Onto simple text, and then like any text, right? And when you look at the speed, like GANs, you had to train for each domain, so that takes days. We moved to pre-trained models, and right when NERFs were 30 minutes, it went down to 6 minutes. So big improvements on those two axes. But you know what didn't improve nearly as much over the years? The quality of the models. Right? So these are two models generated from two of the softwares that I mentioned earlier. You could see the prompt, and you could see the object. And I think they look pretty impressive. If you look at them closer, you could see, though, that it's not necessarily as sharp as maybe you'd want it to be, right? The the lines and the textures, that there's some hallucinations, like if you look at the windows there at the building. Then if you want to look at the mesh that it creates, so like this house is made out of 50,000 triangles. The X is created out of nearly 30,000 triangles. That's a lot of memory to handle, right, running. And then it's like the surface is kind of lumpy. Now imagine that you wanted to, you're a 3D artist, you want to do something with it. Maybe you want to take the house and remove the base around it. It's not like just selecting a few faces and deleting them. It's like really detailed work to cut it out. Or maybe you want to remove a rock. It's pretty hard to work with that. Now let's say you wanted to retexture, right? Maybe you want a red roof instead, like with tiles, instead of like that blue roof. So here are the UVs, right? So you have like some roof there on the top left, and there's also some roof in the center, and bits and pieces here and there and like everywhere, right? You can't exactly drag a tile on top of it and change it. This would take probably hours to change. So it's like almost like they're telling 3D artists, there's a new workflow, right? It's prompt engineering, right? Write what you want to create, wait a few minutes for the result, and then if it's not quite what you wanted, then since it's not easy to work with, prompt again until you get the thing that you want to achieve. But like 3D artists could do a lot more. So we're envisioning a different tool, and we're building a different tool, something that works within the workflow of 3D artists. So we want output out of Sloyd to be the same as like getting something from a colleague within your studio, right? Something that you could modify and change. And so when we look at our like history, or when we look at the history of automation that we rely on, it starts a lot before 2019 in GANs. It starts a decade earlier, probably, with procedural. So procedural is an automation system that works, maybe, or most likely in the studios that you work in, procedural is used. It's widely used in things like vegetation, in things like environment creation. And that's what we do. We do AI and procedural together by training AI on procedural, so that instead of having the complex controls that you have in procedural systems, you just have simple controls like a text prompt. And then if you think about it, when you think about like creating an environment procedurally, it's about placing objects on top of a surface. Well, if you can have an AI that knows how to place object on a surface, you could also have AI place object in relation to other objects. And then you have AI assembly. It's essentially the same problem to solve, only a bit harder because you need more accuracy here. So we're working on AI assembly as well. But we're doing more than just AI in procedural. We're also doing it parametrically. So parametric means that the volumes and the 3D surfaces that construct the shape are made out of formulas and parameters, a lot like AutoCAD. Although we're not using CAD, we're using a different parametric format. Right? So through that combination of AI, procedural, and parametric together, we can go from the highest level of creating scenes by placing multiple objects in a scene. We can go down to the lower level of one object by assembling parts together into an object, and all the way down to the level of a single of the shapes that, or the parts that create an object, and we can modify the volumes and surfaces of that shape with AI. And here's like an output out of our system. So this house is made out of 5K triangles. You could see that there's more triangles in the areas, like the curvy areas where more are needed. And the UVs, you saw it also in Andreas's part, like there's it automatically UV mapped in a way that you could just drag a tile and put it on top of surfaces. Yeah, and here's a comparison of those two houses made with the same prompt or very similar prompts. And I'm not sure which you'll think is more beautiful, but I'm pretty sure I know which one is easier to work with. So that was, back, okay. So that was about topology. Now we're going to look into a different aspect, which is time, right? How much time does it take to generate? So you've seen with this approach that it's possible to iterate, right? So you can have a model, and then instead of starting over, if you just want to make one change, remove a part, add a part, make a part longer or shorter or thicker or whatever, like you could do it through iterative creation. And everything we do is within seconds. So all those photogrammetry AI techniques are very energy consuming and are very long processes where we use methods that are much lighter. So when we do code to mesh creation, it's something that takes milliseconds. We use language to image transfers, which is about a second of inference time. Segmentation is also about that. And probably the slowest thing we use is large language models, but they also return responses within a few seconds, right? So we think definitely that helps, like iterative design and fast results help in creation process. And the last thing to look at is copyright. Well, I'm sure you were aware of that, and the danger or the risk, legal risk that you have is if you are using Gen AI to produce 3D art, and something within your art could be traced to somebody else's work, right? Because it looks close enough. You're at liability of being of doing a copyright infringement violation. Whereas in our case, we use a combination of artists and machines. So we have artists internally and in the community that are making the parts. They're like manually making the parts, and they're like being compensated for it, and they're explicitly allowing to license it for AI usages. And then we have the machine assembling it together, being able to have text prompting on top of it, and to also train and create new variants on that. So when you're using us, you could probably trace what you're doing to a specific human being, but then you know that that person licensed what you're using for, right? So it's safe to use. And that's pretty much it. So in summary, I guess when you look, I'm not going to summarize everything, but like when you look at like 3D model creation, I'd say evaluate it against those three aspects: the topology, the time to creation, and the impact or the meaning it has on copyright. And I think we're opening for questions right now. Right? Yeah. So you could go and step up to the mics and just be sure to speak into the mic, yeah. Thank you.
Hello?
So maybe we'll do each side. Like, so go ahead, please.
Thanks. I did have a question about the system out-interprets components like you were describing, that it takes those pieces and turns that into a full hard surface model. Can that AI system, I don't know a better word for it, but like elaborate on those pieces? Like say I want like a wagon wheel, turn this into a different kind of wagon wheel with a different amount of spokes or something like that, if that makes sense.
Yeah, that's the. So today you could definitely like change like the spokes and that kind of stuff. That's all like in the parameters. But if you wanted to do something more fundamental, like change this, you know, you have a wagon, change the wheels into a truck wheel, something completely different. That's not possible today, but it's definitely part of kind of the AI assembly work that we're doing to enable crazy combinations like that. Yeah.
Awesome. Thank you.
Yeah. Thanks.
Hi, thanks for this talk. Very, very cool tech.
Thank you.
I'm curious on the business model. Is the plan for this to be like a monthly fee, kind of like what ChatGPT is it? Is it going to be more like you kind of pay per prompt, which is like some of the other, SaaS stuff works? Could you elaborate a little bit on those future plans?
Yeah. So for the web app, there's a credit system, so you only pay for the exports. So you can use it however much you want on the prompting, the customization. It's only when you export. You would use those credits. For the API stuff, then yeah, that's a per prompt fee, yeah.
Gotcha. And is that kind of the plan for a long time, or is that just like right now as you guys are kind of figuring things out?
I'm sure this will change, yeah.
Okay.
That's the only
Thanks.
thing we know.
Thanks for the honest answer.
Okay. Open for feedback on that too, yeah.
Coming from an environment art side of things, I was wondering if you had plans to perhaps include artists creating their own source parts to create modular buildings or modular stuff.
So we want that, let's put it that way. So we're working with like a proprietary format for like the parametric creation right now, which means that like systems have to be made, like the basic parts have to be made in our system. We have like an internal kind of like Houdini tool for that we already like gave some community users the ability to use that, but we're also looking into interoperability between multiple formats. So maybe you'll be able to a bit later down the road to create some parts in AutoCAD or in 3ds Max and import them and then use us for scene creation.
Cool, thanks.
Hey, I'm on the tools side, and I'm really interested. First of all, great talk. And I'm wondering, you were entering prompts in a very verbose manner. Is it possible to like assign shortcuts that you design, you suppose you say, okay, you want to create a building. It's say B space something. And then, that kind of, instead of repeatedly typing the same thing, you could like do that shortcut and then.
It's a good idea, yeah.
Okay, copyright it.
Yeah.
But the other question is, I did see on the slides, some integration with Roblox, Unity, Unreal. Is that designed to be a plugin that we can use in the future?
Eventually, that's what we want to do, yeah. Today, you have to kind of export and bring them in. But, yeah.
We have a Unity plugin.
Yeah.
And we're definitely working on a Maya plugin, right? So those are available for companies, right? Yeah, but like
Got it.
We'll expand. And like I know tool creators like love their shortcuts. Yeah, but like I mean we're like working with like language models and stuff like that. Like it mostly understands human, the way humans converse, but we could add shortcuts on top of that.
Mm-hmm. I guess, the base implementation, and then we'll see where that goes. Yeah. Thank you.
Thanks.
Yes, hey. So from what it looked like, you are working with both the parts and then the assembly, and it looked like you had basically training on the human-made parts, but it looked like it was able to extrapolate. So I just wanted to ask: is the creation of the individual parts a process where it learns how to make the part from a collection that you've licensed, rather than just only taking the lowest level meshes that were just created, and so it can't use an infinite number of wheels? It has 20 wheels it can assemble with.
So I'm not sure if I understood the question fully, but let me try.
Basically, you use human-created assets for wheels, for example. Does it then learn to make wheels based off of those assets, or does it just use those wheels to create assemblies?
So it takes the created parts that are all customizable and uses those in the objects. If that answers
All right,
your
thank you.
question.
We plan to have it create new variations, but we're kind of looking at being able to achieve the same quality that we have on the base objects before we put something like that out. Right now it assembles existing parts.
Yeah, that was exactly what I was wondering. Thank you.
Yeah, thanks.
Hi, it's a great talk. Thank you. So I have a question regarding the parametric AI sort of UI. So are you grouping different 3D primitives together of different like object types? So like if you have different models of...
Sorry, can you speak into the mic?
Oh, sorry. So I have a question regarding the 3D AI / parametric procedural part of the process. So are you grouping different groups of 3D primitives, like different models of cars and different architectural styles of houses and like, you know, having like different artifacts where you can adjust? Are you grouping the primitives together as sort of a way to curate, oh, if you have a house that's designed this way and it's of this particular architectural style, are you using a slider to say, hey, this artifact will go this way because it has this artifact? Is there a data set like grouping different primitives together when you're doing all this procedural parametric stuff?
And by primitives, you mean kind of styles, really?
Yes, styles of different assets, houses, cars, sci-fi props, etc.
Do you want me to try? So I think with like we expose parameters, and a parameter could be making something thicker or making something rounder, and the model has an understanding, like its own implicit understanding of style, and if you say make it more cartoony, it would probably make things curvier, it would probably make things thicker than they are right now, and it would like, you know, pull on many things together and get you closer to that style that you want. So that's the interesting part. Like you don't design the style into, you just design the basic parameters, and AI understands to like how to use them towards a style.
Got it. So the text to 3D asset, the level of detail that it can access is like, curvilinear, like it's less of the architectural style, but more of like the shape language, basically.
Yeah, there are two things to it. It might replace things modularly, right? So think about like kit bashing. It could take parts and change, but then it could go into parts and it could do exactly the things that you say, like, for example, curving them, changing dimensions and stuff like that. Yeah.
Okay, so this is more of a shape language, less of like, hey, this car model of this particular, okay, got it. Thank you, sir, appreciate it.
Yeah. So for the parametric manipulation, is there from the example you showcase, is there a limit? There's only so far it can go depending on how complex the model is. Given the example you showcased was some kind of wheeled robot, I imagine like if the example were like instead were the model for like from some kind of quadruped robot, like I imagine there would be some kind of limitation to how far it can go. Is that correct?
Today it is, yes. That's correct, yeah.
Hi. I have a question related to Steam. So as far as I'm aware, when you publish on Steam, you guys are nodding your head, you have to disclose and warrant it's non-infringing. And I see on the Sloyd terms that it's licensed, which is probably fine. But then I'm wondering, have you received any feedback on challenges or success stories about that process releasing the game? And are you like working on building a relationship with Steam so that it's easy for developers? I'm not quite sure.
Yeah, we're trying. They're a bit hard to get a hold of, to be honest. Like directly, they're like referring everyone to kind of the open process. But from what we understand, there's not really a problem because the assets themselves are like we own all the. What you have to kind of provide in terms of details is where does the data come from, and all the detail all our data is our own. So it's very simple in that sense.
Okay, and then I'm assuming everything is logged, so we can just.
Sorry?
Everything would be logged from the user side, so there's just...
Yeah. So you can like prompt them Mickey Mouse, or something like that. Yeah, exactly.
Cool.
Yeah.
Thank you.
Yeah, thanks.
I really like it too. Thank you.
Thanks. Great talk.
Thanks.
I thought it was awesome.
Thank you.
One broader point, was thinking about listening to all the questions. From a community standpoint, you're developing the software for people to use, for artists to use within their development pipeline. In terms of keeping the tool alive, like as a living creature, and making sure that like you're taking feedback, taking in that like cool idea about prompts, like shortcuts, what's your guys' policy? Like, how do you want to approach keeping this tool in a development state for the community? Like new ideas? Do you have like a direct outlet for that, for suggestions, or is that something you're looking into?
Yeah, we have a Discord, so you can jump in there and just pop in whatever suggestions you have. You can go to place an email or whatever, and we'll always read that. We for every new sign up, we send a survey too, so we collect feedback that way. Mm-hmm. So yeah, we're definitely listening to as much feedback as possible. Yeah.
Cool. Thank you.
Thanks. Final one.
Hi. 2 more questions. First of all, what about target poly counts?
Oh yeah. So like typing in, I want this to be maximum.
Yeah, like max 5,000 poll, 5,000 tries.
Oh, I would love that. Yeah.
Someday down the line, perhaps.
Yeah.
Okay.
It's not something we have, but we need to work on that essentially. Yeah.
Cool.
Yeah.
And on the export side, I know we like clearly work with FBXs and stuff like that. But what about USDs?
USDs? Yeah.
Yeah.
So currently we support OBJ and GLB.
Okay.
And so probably we'll get
Because
we definitely
exporting
want
full-on
USD,
USD scenes that
What?
could exporting full-on USD scenes packed.
Yeah. It's definitely on the
That's-
roadmap as
okay.
well. Yeah.
That's on the roadmap.
Yeah.
Cool.
Yeah.
Thank you.
Thank you. All right. I guess that's it. Enjoy the rest of your days.
Thank you.